everybody. Today we're going to work on composition of functions. Now this is something that we talked a little bit about before, just to give you a basic idea of what we're doing. Let's say I have f of x equals x squared, and I want to know f of 2. Okay, well hopefully everybody at this point knows you plug in 2 for x, okay, and you solve. So f of 2 will give you 4 in this case. That's what we're doing, but we're going to do it with several different functions. Instead of just having one function and plugging in a number, we're going to have two functions and plug them into each other. So I'll show you what I mean. F of x is 1 over x, and g of x is 3x minus 6. Now, they want us to find f of g of x and g of f of x. Okay? Now, I know the notation looks a little confusing, but it's not bad. Okay, they want f of g of x. So everywhere we see x in the f of x function, we are going to plug in g of x. Okay, so f of g of x is going to equal, well, I need the f of x function, well, that's 1 over x, but instead of x, I'm going to plug in g of x down here. 3x minus 6. Okay, now is there anything to solve there? Not really. Let's talk domain. What's the domain of this? The only problem I'm going to have is when it equals 0. So let's set it equal to 0 and figure out what that number would be. 3x equals 6, so x equals 1/2. So the domain for this one, x cannot be 1/2. Now I know I didn't ask for that, but it will on the homework, so that's just good practice. Now we need to go the other way. Now we need g of f of x. So now we're going to take the g of x function, do this in green this time. We take the g of x function, and everywhere there's an x, we're going to plug in the f of x function. Okay? So g of f of x is going to equal, well, the g of x is 3, and then there's an x, so I plug in the f of x function, which is 1 over x minus 6. Okay? Well, if there's any simplifying I can do, let's do it. It's going to equal 3 over x minus 6. That's about it. My only domain problem, x cannot equal 0. Okay, get in the habit of looking for domain things on all these problems. Okay, another example here. F of x is x squared. G of x is the square root of x minus 2. They want us to find f of g of x and give the domain. F of g of x and find the domain. So that means I need to find f of x. And I'm going to plug in g of x, okay, and make sure everything works. So f of g of x equals, well, f of x is x squared, but I'm going to plug in the g of x for x minus 2 squared. Okay? Hopefully we're seeing that. I'm just taking this and plugging it in for x. Okay? So f of g of x equals, now the square root of anything squared is x minus 2. What is the domain of this? Okay, well, the domain of this is all real numbers, according to this. Okay, it's all real numbers, but there's a problem there, because not all of the numbers are going to satisfy each function independently. Okay? Where am I going to have problems here with this function? With the square root of x minus 2, that is still something we got to work with. X can't be 2, so I can't use all real numbers. I have to use each function independently, so my domain x cannot equal positive 2, or no, excuse me, x has to be greater than or equal to 2, because otherwise we have negative numbers. Okay? There's our domain, that's what we're looking at. Okay? We'll make sure we get all the domain stuff handled. Hopefully we're getting better with it. My main concern is being able to plug in and simplify functions when you're plugging functions into other functions. Okay? Hopefully this all makes sense. I'm not sure when we're going to see each other again in class, whether it's Friday or Monday, but we will definitely review this when we get here.